Hello everyone. In today's video, we are going to learn about subset. What is subset? Okay, so let's consider a situation. Okay, let's consider a case where we are taking your class, your whole class. Let's suppose that is set Y. It means all the students of your class is set Y. Now, there will be few children who will be living nearby, or let's take a set X where we are including the children who live within 5 kilometers of a school. Okay, now both are sets. Both are sets. But how these two sets are related to each other? Because whatever the elements are there in that, it means the children who lives within 5 kilometer radius are part of your class. And there are few children who don't live in that radius, but still they are part of your class. So how these two things are related to each other? So here, everyone in X means who lives within 5 kilometer is also in Y. So what we call it, the smaller set is called subset of what? Subset of Y. Are you getting? It is subset of Y. So if you picturize it, you can see that this one, this is set Y. It is denoting all the children of your class. Out of that, X is denoting who all are living nearby to the school, right? Then as this small set is a part of small y, part means all the elements, all the children who are there in this X set are also in set Y because they are a part of your class. So they are called subset of this bigger set. It means subset of your class. So how we write it? We write X is a subset of Y. And this is the symbol of subset. This U and then this line. This is the symbol of subset. So we write it as small set X is a subset of that bigger set Y. Okay. Now, let's see the definition, proper definition of this one. So set A is said to be a subset of set B. It means set A is smaller, that is why it is subset, and set B is bigger. If and only if every element of A is also belongs to element of B. It means what we can say here, if suppose there is element X, if it belongs to A, then it will surely belongs to B. If it is happening, then we can say that A is a subset of B. Okay. So symbolically, I already explained how to write. Now, if suppose A is not the subset of B, there's an element Y which belongs to A, but it does not belongs to B. So as is it does not belongs to B, there are some elements which are in A but not in B. For example, it's not necessary that your class children are only living nearby to the school. There will be other class children also who will be living nearby to the school. So if I take the set of all the children who lives nearby to the school will not be the set or will not be the subset of your class. Reason? There will be some children who will be studying in grade 10 or there will be some children who will be studying in grade 8. But as the bigger set we are considering as grade 9, there are few children who are not in part of your class. So then we can say that that set or those children who are living nearby are not the subset of your class. So if not the subset, how we represent it? We represent it like this. Okay. This is the symbol of not subset. It is same like that. Equal to, not equal to. Belongs to, not belongs to. Subset, not subset. Okay. Now in words, what you can write? Every element of A is an element of B. Okay. So what we can think? We can think that subset is a smaller box that can be fixed in this bigger box. Okay, that can be fixed in this bigger box. Let's take one example. There is a set A containing element 1, 2, and 3. And there's another set B which contains element 1, 2, 3, 4, and 5. So all the elements of A are there in B, yes or no? 1, yes, 1, 2, 2, 3, 3, yes. So since every element of A is in B, so what we can say? We can say that yes, A is a subset of B. Let's take another example. A has A, B, and B has element A, B, C, and D. So A is there, A is also here. B belongs to A, then B belongs to B also. So all the elements of A are there in B, so we call it A is subset of B. Right? Now let's take one more example. A 1, 2, and 3, and B 1, 2. So 1 is here, 1 is here. 2 is there in A, 2 is there in B. 3 is there in A, but 3 is not there in B. Then what you can say? As 3 doesn't belongs to B, we can say that A is not the subset of B. Right? So A is not the subset of B. So not every element of A in B, it means A is not a subset of B. Now, what about 5? Remember 5? What is 5? 5 empty set, null set, void set. Okay, as empty set does not have any element. It has no element. So will it be the subset of any set? Yes, as it has no element, it means it is a subset of all the elements, all the sets. Okay, so what we can say, the empty set phi is subset of every element because phi has no element. And the condition that every element of phi is in P is always satisfied because it does not have any elements. Obviously, it is satisfied. Now, let's consider a case A as 1, 2, 3, and B also 1, 2, 3. Right? So all the elements of A are there in B. 1 belongs to A, 1 belongs to B. 2 belongs to A, 2 belongs to B. 3 belongs to A, 3 belongs to B. It means here also we can write A is subset of B. Right? But sometimes, as we have seen here in these two examples, there are few elements which are left in the bigger set. If any element is left in the bigger set, then what we say? We say that the smaller set, okay, we say that the smaller set is a proper subset of B. This is the symbol of subset. This says that all the elements of A are there in B. Right? So here also this condition is satisfied. This sign shows equal. It means if in elements in A and B are same, right? Exactly same, then we can write them like that. But if suppose there are some elements left out, then we use this sign. This is the sign of proper subset. Like here you have seen A is a small set, B is a bigger set. So A is subset of B. Either you write like this or you write like this, both are correct. But for proper subset, whenever we use that word proper, this is the correct symbol to use. So this is now in that case, A is not the proper subset because it is completely the set. So apart from this example, where all the elements of A are elements of B, remaining all the subsets, all the other sets are the subsets of this bigger set, B. Okay? Now, yes, let's see some examples. Now you have to use this notation, subset notation. Okay? And you have to check which set is the subset of the other in the following problem. Now here A is 2, 3, P. B is 1, 2, 3, P, Q. You have to check whether A is a subset of B or not. 2, yes, 2 is belongs to B. 3 belongs to A, 3 belongs to B also. P belongs to A, P belongs to B also. Yes, so what we can say? A is the subset of B. Now here A, 2, O. What is B? B is null set. It means in B there is no element. So whatever the element are there in A are not in B. So what we say that it is not the subset of B. Now next A. Here 3. Here we have 3. Here 8. Here also we have 8. 9 and 0. 9 and 0. So yes, this is subset of B. Now next. A equals to 2n where n belongs to n. Right? And here x equals to 4n where n belongs to n. So 2n, it means in roster form what we can write? We can write it as 2, 4, 6, 8, 10 and so on. In this what we can write? Multiple of 4. So 4, 8, 12, 16 and so on. So 2 is there in A. Is 2 there in B? No. So it is not the subset of B. Right? So what we have learned today? We have learned that if we are saying that A is a subset of B, it means that every element of A is a subset of B, or every element of A is there in B. If we are saying that A is not a subset of B, it means there will be at least one element which is not there in B. Phi, yes, phi is a subset of any element, any set. And if we are saying that A is a subset of B, but both the sets are not equal, then we call it A as proper subset of B, right? Okay. So in this video, that's all. So keep revising, keep practicing, and stay happy with maths. Bye-bye.